Thank you for coming. I wasn't expecting this crowd after the party, but I think you all want to know how to optimize your network for Microsoft Teams, right? So let me go in early, because I'm starting 1 minute early, because I'll probably need a lot of time. So let me tell you a little bit about myself. I'm Johan Delliman. I come from Belgium. I work with the collective in Belgium, focusing on Microsoft 365. I'm an 11 years MVP, focusing on Microsoft Skype for Business and Microsoft Teams. So we are talking about optimizing the network today. So first of all, I have to say, I'm kind of have to explain like setting the scene. Like, why do we have to optimize the network? Why isn't it ready by default, right? We have to ask that question. So the thing we say is like, keep calm and blame the network, because it's always the fault of the network. It's the network to blame. So take this in, but don't keep it for a long time, because actually I'm going to say it's not the network. It's not a network because maybe you didn't do your job well enough to prepare the deployment of Microsoft Teams, because you have to do or check a lot of things before you deploy it. And I'm going to explain why. So in the early days, I'm going back to maybe the 80s and the 90s, so pre-internet age, it was like people had a corporate network, and they had some server resources and some clients. And don't worry about the Skype logos. Skype wasn't there yet, but it's just an example. So, and all the clients essentially connected locally to the resources within the network. Everything was fine. We didn't have to worry about internet or any security threats from there. Now, of course, when things change, internet became available, and we all want to connect to internet, right? So, but how do we connect to internet? Right? We actually implement proxy servers, we implement firewalls, so suddenly we have additional network devices in our network that we need to be aware of, right? So what happens if those users connect to internet, they go to the proxy goes to the firewall, it's all secured, because we don't want to get threats from the internet. So there are very good reasons to do this, right? Because we want to have security, control, compliance, whatsoever. All of those tools, well, it's valid reasons to have those components in place. So essentially, this means that the entire internet, I put it in red because the trust is 0. Like, we don't trust the internet. That's the basic fact. We don't trust the internet. And that's fine, because in the early days, we still had local resources. So essentially, when internet was there, we had the opportunity to work from home, and then we had to extend our network to the home as well. So what happens is that people, well, we weren't publishing resources through firewalls because we were more doing VPN, right? VPN is still in place at almost every company I go into. Like, VPN allows access to those resources through the VPN tunnel, right? So essentially, if you look at the trust model, still, the internet is not trusted. Okay, the home location may be more trusted now, and the tunnel to the corporate network is trusted. Now, of course, when we actually go further, and this current age, we have a lot of cloud resources. We have Teams and Skype for Business. We have Office 365. And of course, how do we access those resources? Usually, it's exactly the same way as we access the internet. So we go through a proxy, we go through a firewall, we connect to our services. Now, is it a good idea to do? Maybe from a security point of view, yes, but for quality and media optimization, probably not. So we have to work on that. So people in remote sites potentially go to one central location, break out to the internet, which is also not a really great idea, because there's going to be more latency. And additionally, the people connecting through the VPN exactly use the same path, right? So we all have to take care about this. And when we look at the trust model, Office 365, Microsoft 365, Skype and Teams, they are not a trusted resource. So we cannot just send data there and receive data without being impacted by network equipment, right? It's still going through all those network metrics. So what's wrong with this? So essentially, we have to fix a lot of these issues. We have to be aware that proxy servers are probably not the best choice when we connect to Office 365. Firewalls, we need to open up sufficient ports so that we can connect securely to Office 365 and that we allow traffic to be there, to go there, and have good quality. We have to think about the VPNs because the VPNs are not optimized because we don't want to hairpin through our corporate network because the quality will not be there. Remote offices we have to think about, and we have to make sure that Office 365 is a trusted resource. So how are we going to do this? We're going to fix some of those issues. So first of all, we have to tackle the reverse proxy component. So the reverse proxy, essentially we say, either we remove the reverse proxy, which maybe is not a good idea because we still need security, but we need to make sure that if we connect to Office 365, that the proxy is not involved, right? We have to go next to the proxy so that it doesn't go through. So essentially, we want to try to connect to Office 365 directly, but now, okay, we didn't do anything on the firewall level yet, so that probably is not going to work, right? So we still have to do some work there. So let's first check, well, and of course the solutions are remove the proxy server or do proper proxy server configuration so that we don't do, or we bypass the proxy for certain URLs. So how do we do this? In most companies where I work, we have the proxy point pack file where there's a long list of exceptions. And you can put a long list of exceptions in there, and then you can say all the URLs for Office 365, they are not going through the proxy. It's a good idea, right? It's not the best solution because those URLs, and I will show them in a minute, there's a long list of URLs, right? And they change regularly because new services come on. So you have to check that maybe every week, every month, and update your configuration. So other things you can do is GPOs for Internet Explorer. I have some companies that just use direct connection to Internet too. You don't really need a proxy server. Depends on your security level, of course, because you can remove the proxy server too. And then let's look at these URLs. You can actually get all of the URLs and the IP addresses that Office 365, Microsoft Teams, Skype for Business are using. But of course, this is the list, right? So you see there's URLs in here, .link.com, Teams, Microsoft.com, Teams, Microsoft.com, and there's a whole other list of URLs. So essentially, this is interesting to know, but you have to update your configuration probably a lot of times. So Microsoft essentially has a web service that gives you back all of the IP addresses and URLs that you need to use. Now, this web service, you probably don't want to use it as an admin. You probably want to have a solution in place that automatically works with those web services. Like there are proxies out there that can consume those web services and allow the URLs automatically. This is what you should do. So secondly, we have the firewalls, because we have to tackle the firewalls too, right? Because now we fixed the proxy issue, we still need to focus on the firewalls. So in this case, we say, okay, let's do the right and the proper configuration on the firewall so that those clients can access those resources. And then life is good, right? So we allow the IPs and allow the required ports. So if you don't allow just the IPs and you just want to block the ports or allow the proper ports to work, you have to do a little bit more work. But they are all in here, right? So this is a long list of IP addresses and ports they all need to open to Microsoft Teams. Now, if there is one rule that you have to apply, it is this one, TCP 443, and we have UDP 3478 to 34781. So these are the media ports. Optimizing the media ports will already give you more quality, right? But you should do all of the configuration. So now that we know how to fix the firewall too, we still have to tackle VPN. VPN is important here because we still hairpin through the tunnel, but essentially we should do this, like node Teams traffic should go through the tunnel. And I really mean no Teams traffic, also not the internal connections to internal users. So essentially, we should bypass the tunnel completely and go directly to Microsoft 365. Now, this may seem easy. It's not a checkbox on the VPN that you say, oh, let's just bypass the VPN. No, there's a really important component here. You need to have configured split tunneling. Now, in most companies where I work, they don't use split tunneling. And if you say, I want to use split tunneling, the security guys will say, whoa, are you crazy? We're not doing that. So it usually takes a little bit of persuasion and a lot of work in order to help them understand that this is really crucial, right? So you have to put a lot of work in there. So we need split tunnel, and then all the IPs from Office 365 we have to exclude from the tunnel, and then also the media ports for the clients connecting from the internal network. So again, we have all the URLs here, and then when we get to this stage, essentially we have configured Office 365 to be a trusted resource, right? Because now we have configured Microsoft 365 to be a trusted source and destination. So those three things help you a lot, right? In optimizing the quality for Skype for Business and Microsoft Teams. But it doesn't just stop there, because we still have to do some other work. Like, it doesn't necessarily say that we have a great connection to Office 365, because this part of the network we can't control, but maybe we do control it a little bit and we can test it. And then for remote sites, we still have to do some work, because we don't want to use a central breakout to internet. So we'll have to look at round-trip delay and internet breakouts. So first of all, we connect from a client to a transport relay. So all the stuff that you see in here are transport relays. And essentially, those transport relays are resources that you connect as close as possible, right? So I wouldn't say in every country, but like really close to you, you will probably have a transport relay. So that means if you connect as close as possible to a transport relay, Microsoft takes care of their internal network, and it's really high speed and really performing. So you shouldn't have to worry about Microsoft network, just about what is the connection to this transport relay, right? It should be as close as possible to your location, your internet breakout. So then you may ask the question, like, for remote sites, are we essentially using the same internet breakout? We probably don't want to use that, because to optimize this, we should configure maybe a firewall in here and have an internet breakout locally, so that these guys actually connect as fast as possible to another transport relay close to where we exit internet. So, and then Microsoft takes care of the connection on their internal network. So how do we fix those delays? And how do we even know there are delays, right? How do we know the connection is good or not? Like, luckily, we have a tool from Microsoft available to do some testing. So this tool will test the connections to Microsoft, and essentially you have to look at target for clients. So this means your PC running on your internal network. This client, this testing client, you can install on any device, and it will do the test for you. And it will show you what's the result of this test. So essentially, the most important values are round-trip time, which means going to Office 365 and back, should not be more than 100 milliseconds. Microsoft takes care of the rest of that network. Of course, packet loss should not be high, right? We don't really like packet loss. And jitter inter-arrival of packets should be under 30 milliseconds. Jitter inter-arrival of packets means that packets are received in the different order, and we have to bundle them again and to order them in the right sequence. So if this buffer runs out, then we lose packets as well. So jitter is also important here. Now, how does this tool work? So essentially, you have to do two tests, like from your external network connection to internet on your DMZ, your router, whatever connects to internet, you have to run this from your network edge, so that you know, like, this is the minimum network traffic that we need, right? And then you have to see, like, our clients, they connect to those same transport relays or maybe a different one, but what is their connection, right? And if the difference is too high between your network edge and your client, maybe you have to do some work there to optimize the network. And of course, we can do that in multiple locations. We can do network edge tests here and then client tests over here. So this tool is called Skype for Business and Microsoft Teams Network Assessment Tool. Originally built for Skype for Business, but still works for Microsoft Teams, right? So it's a free public tool. You can download it. It's a command line tool, and it looks more or less like this. So essentially here you see some test calls going on, and you see results coming back. For example, round-trip latency is 12 milliseconds. We have 10 milliseconds jitter. So you can actually test what is my network connection to Office 365 and how good is it performing. Then you have to look at the table we showed previously to actually validate. But this tool does also another interesting thing. It does connectivity checks. So if you say, run this tool, and you do connectivity checks, it will check all the transport relays and the ports, whether it can connect to them, right? It says, UDP port 3478 is available, TCP 443 is available, so it will test all the relays, all of them. So that's an interesting thing to see, right? So that you can validate, did we actually configure the firewalls correctly? So you can use this tool, and then essentially, when you do those tests, it's not just running a test only once, right? You have to do this for a longer period of time. So essentially, it's best to do this at least a week, and then collect the data. And what I did with a client of mine, I looked at Wi-Fi inside, Ethernet inside over the VPN, and then Ethernet over Internet, and I compared all of those values. So the only one that's a little bit cumbersome here is the average jitter in milliseconds, which is 60. If you look at the max that I counted here, because essentially we have to look at the max, because, well, we don't want to have just one, or all the calls are good except one. No, we want all calls to be good, right? That's the intention. So 60, do you remember what the actual value was we should have? Like under 30. Like maybe we have to do something on the Wi-Fi network here. And then essentially you can draw this out on Excel if you want. And well, we once had a peak here, so I'm not sure if it's really important, but if you see more peaks, then it's probably more important. Like the average jitter inter-arrival, essentially it says it has to be under 30 milliseconds all the time, and we have probably like 10 hits, and this was just 1 hour of test. So the jitter is maybe not really good. We have to work on the jitter in this case. So now that we know our connection to Office 365 is good, we still can do some additional work to more optimize our network. So we can look at QoS and internal firewalls. So sometimes when clients want to talk to each other, so this client and that client, sometimes there's a firewall in between, and which is going to block the media stream. Because if people or clients talk to each other, they will most likely go direct. And we want it to go direct because that's the most optimal path to take, right? So is there a firewall blocking this call, essentially? It will still work because there's a side effect of the transport relays that we will actually go to internet and hairpin over the transport relay to get a media flow going. But you see, this is not really optimal, right? Like, we are losing at least some milliseconds going to the transport relay, and maybe we're losing some packets in the way as well, which is not good, right? So essentially, we have to say, let's configure the firewall. Oh, yeah, and it can happen in the same way if we connect between multiple sites as well. So a firewall can be misconfigured here too, and then potentially we route through different transport relays. So what we essentially want to do is allow the proxy servers to have this the firewalls to allow these ports to communicate between the clients. So you remember the ports, TCP 443, and then UDP 3478 until 3481, right? So they have to be allowed through the firewall. And the same way for the remote side. Now, if you look at those port ranges, these are kind of important because those are the port ranges also going to be used for the media flows. So I made a small mistake here. So it's not the UDP ports 3478. It's the client port ranges that we need to allow, and it's these client port ranges. So these are the default ones that Microsoft 365 has configured for Skype for Business and Microsoft Teams. So 50,000 until 50,019 for audio, and then we have video, application sharing, file sharing. So if you want to do QoS2, you also take into account those port ranges, because you have to create GPOs and say anything going out from link.exe or teams.exe, going from these ports is going to be audio. We're going to tag it in this way. That's done through GPOs. Now, some time ago, Microsoft actually enabled custom port ranges in the Teams Admin Center. So you can actually configure different port ranges if you want, because potentially some other application is using those port ranges, and your network team will say, well, I don't agree, we cannot use those port ranges. Then you can go in here and change those values, right? And then one other thing that you can do is enable QoS. We can enable QoS from here. Microsoft is working on automatically enabling QoS, but for now we still have to do GPOs and like configuration in Windows to enable those tagging of ports. So if you look at, if we want to tag for QoS, we have to use those values. And Microsoft says you cannot change the values. I'm not really sure what the reason behind that is, because in my opinion, you can change it. But if you look at QoS, we would use DSCP 46, 46 for audio, 43 for 34 for video, and 18 for application sharing. So essentially, we have to look at the port ranges. If you customize the port ranges, you have to customize it in here as well, right? And it's both UDP and TCP, because we are going to use both. Of course, we prefer UDP for audio and video, and probably application sharing, but we can fall back to TCP if required, if something is blocked. So this is the configuration we should do. So the port ranges are adjustable. The DSCP markers are not configurable. This comes directly from Microsoft documentation. I still want to find out why they say that. But Teams respect the existing configuration you have for Skype for Business. So essentially, you need to add teams.exe to your already configured tags for Skype for Business. So that leaves us for a summary. So what do we have to do to optimize our network for Microsoft Teams? So first of all, proxy servers. Second, firewalls. Third, we have to look at VPNs. We have to look at round-trip delays, local internet breakouts, right? The testing, your connection to Office 365, and then QoS internally and internal firewalls. So thank you very much for attending. And if you have any questions, feel free to come up to me at the site.